Let's see if it started. Oh yeah, we're filming again. All right. I want to find out when the acceleration equals 0. 6t minus 12 equals 0, t equals 2. Now, this is the scary part because I've got the camera on there and I'm about to put the acceleration here. I normally would put the acceleration underneath here, but I'm going to put it above it right now, if that's okay. Is that all right? Y'all put it underneath on y'all's notes. Okay, I'm going to put t equals 2 right here. And that's where the acceleration is equal to 0. A of 2 equals 0. Notice I put it between t equals 1 and t equals 3 because down here I do have a what? Timeline. Is that okay? That's a timeline down there. So we're good. Now, if I put a time smaller than 2 into the acceleration, I put in 1, I put in -5, I get a negative acceleration. So all the time less than 2, we have a negative acceleration. That's okay. It can be going that way with a negative acceleration. It can be backing up with a negative acceleration. All right? But we have a negative acceleration. You might think about this. If it's going that way, the negative acceleration is fighting against it, right? If it's going that way, the positive acceleration would be doing what? Pushing it on a little what? Faster. And that moment it stopped at t equals 1, it had a negative acceleration. That's made it go what? Start going back that way. Now, please don't change what you already know from the velocity. Okay? The directions are set. Acceleration is just telling you more information, but the directions are set. Put a number bigger than 2 in there, and you get what kind of acceleration? Positive. Positive acceleration. Now, what I'm going to do is I'm going to find out where it's at 2. And somebody says, Mr. Evans, at 2, it's at 3. And I think you're right, but try it and see. Let's find out what the position is at 2. And since this is a polynomial, and I'm a pretty good guesser, I'm going to say it's 3. So right here, t equals 2, position is what? 3. That peak point is not... Now, how did I know it went there and not up here or not down here? How did I know it went there? Because this is what? T equals 1, right? That's what? T equals 3. So t equals 2 has to be between those, so it's on this part. Is that okay? Because everything here is before 1 second or 1 minute. Everything here to here is between 1 and 3. And then after 3 seconds, it's going back that way. So all of this path, here, the turnaround, and the time going back to here, the acceleration is negative. Then, at this moment, the acceleration starts being what? Positive. All right? So, I'm going to put, I kind of want to put, I'm going to put some little negatives to show that's acceleration. They're in different colors, so that's negative acceleration. And then at that moment there, you start getting what kind of acceleration? Positive. And they're in pink, so you should realize these positive negatives are about what? Acceleration. Notice, I didn't have to do that for velocity, because if it's moving to the right, the velocity is what? Positive. If it's moving to the left, the velocity is negative. But for acceleration, it can be moving either direction and I can have a positive acceleration. Is everybody understanding that? Notice I'm really trying to get you onto that idea that the acceleration can be positive and it can be moving in either direction. All right? Okay. I look at my watch and I think, oh God, I really can't believe I'm teaching all this today. That's right. Okay. I'm going to try this. I'm going to make a little chart, and we're going to talk about some things here. We're going to come back and look at this after I make my little chart. All right? Is it okay if I erase this little part right in here and make my little chart? All right? And everybody's got this little bit down here, right? But I'm going to erase that little bit of math and I'm going to make a little chart. All right. And we're not going to work with the numbers from this problem. We've got all the information from this problem that we need the math for, all the steps. What I want to do is just talk to you a little bit about speed. Okay. I'm going to make a little velocity and acceleration chart. Velocity, acceleration, and speed. Okay. If I have a positive velocity, I'm going that way. I'm going in the positive direction. If I have a positive velocity, I have to be going in the what? Positive direction. That can't change. And I have a positive acceleration. What do you think is happening to the speed?
It's increasing.
It's increasing. Because I'm going positive velocity and a positive acceleration. It's making me speed up. So the speed will increase. And I'm going to stay in the positive direction. Do I have to write positive direction there? Because you already know it's got to be in the what? Positive direction because of the velocity. Okay? Now, we threw the ball up in the air. It had a positive velocity, but it had a negative acceleration. What did it do as it was going up? It what? Slowed down. Does everybody agree? Positive velocity, negative acceleration, it's going to do what? The speed is actually going to slow down. Decreases. In other words, the velocity goes from 50, 20 to 0. Is that okay? The speed itself decreases. Now, the ball starts towards the ground. We now have a negative velocity and we have a negative acceleration. Now remember, the ball's going towards the ground. The negative tells us that it has to be, if the velocity is negative, it's got to be going in the negative direction. But what happens to the speed as that ball comes back out of my hand? It increases. Everybody can see it happening, right? Speed is what? Increasing. Yeah, the speed increases. Somebody says, well, how does the velocity get smaller and the speed increase? Because the acceleration does make the velocity get smaller. Well, let's look at this. This does not have anything to do with that chart. I'm just going to make this. Let's say I go negative 30, negative 50, negative 60, negative 70. And I told you those were the velocities. Does everybody agree that's getting smaller? Right? But what happens when you take the absolute values? They get bigger. See, negative 60 and then negative 80, yeah, the velocity got smaller, but you're really going faster in reverse. Is that all right? Yeah. I want y'all to honor this chart, because this chart will help you. Now, I have a negative velocity, but I have a positive acceleration. Okay, what's going to happen there? I have a negative velocity, and I have a positive acceleration. Look what it did. It ended up doing what? Stopping, right? It's got to be doing what? Slowing down. All right? Is that okay? Is that right? Slows down. So the speed does what? Decreases. Now, speed decreases. Please trust, but the velocity tells you the direction. Both of these are moving in the positive direction. Both of these are moving in the what? Negative direction. Okay. All right. So, if you're looking at the speed here, this whole time you had a positive velocity and a negative acceleration. So what's the particle doing? Is it's slowing down, slowing down, slowing down, and it does what? It stops. Now you have a negative velocity and negative acceleration, so it starts going backwards, and it's going backwards, the speed is increasing. Speed's increasing, but it's going what? Backwards. And at this moment right here, your acceleration turns positive while your velocity is still negative. What does it do? The speed starts doing what? Decreasing. And then it stops, and then they're both positive. So what happens to the speed as it goes this way? It's always in what? Increasing. Is that cool? It's not supposed to be totally right in your brain yet, because you got to think about it and deal with it. But what happens is, if you have this chart and you get this information, you can start interpreting a lot about what you need in physics. Now, to be honest, particles usually take 3 steps forward, 1 step back, 3 steps forward, 1 step back, 3 steps forward, 1 step back. But we can't do anything that complicated yet because we don't know how to take the derivative of trig functions. Trig functions deal with that problem of moving, backing up, moving, backing up, moving, backing up, and that kind of thing. But we're not there yet. That is one-dimensional motion. When you look in Leipold, he's going to have 9, 11, and 13. That's the only 3 I'm giving you. But I want you to do everything I just did. I'm not even sure he talks about acceleration yet, because he waits until another section to do the acceleration. It's in 310. And y'all remember when y'all talked about acceleration in class, and y'all would put it feet per second squared? Acceleration due to gravity is feet per what? Second squared. All right, when I did that little acceleration thing a moment ago, you had the change in position with respect to the change in time with respect to the change in what? Time. Feet, position, seconds, and seconds, that becomes what? Seconds what? Squared. Turn into one fraction, take the reciprocal of that, multiply to the degree, you get change in t squared, right? And that's the reason acceleration works out to be a distance, a position, distance over a time squared. Feet over what? Second squared, whatever. That's the reason that works that way. Feet over second squared, especially when you talk about gravity. And we're going to work a problem or two about shooting the rocket up. We can't do the problem we're going to do with a rocket because you continue to have energy put into the rocket as it goes up. We're going to talk about just firing something up with the energy sitting there and it comes back. All right. Please don't trust all my terms as far as energy and all that. But when you're talking about the velocity, the acceleration, the speed, use that chart to interpret what's happening. And then you make, but remember, you got to make this chart for velocity. Please don't be the kid that makes the velocity chart and the acceleration chart over here at the same time. Too confusing. Make the velocity chart, trace the movement of the little ball. Okay? Then go back and talk about acceleration. Because if you try to get all that information and then put it over here, that's when you start having it go in the wrong direction. Acceleration is not the direction. Now, the last bit of knowledge for today, something that's fun to teach. What the change in acceleration with respect to time equals question mark. What is the change in acceleration with respect to time? Sir? No, change in velocity with respect to time is acceleration. Okay? See, if you change the position with respect to time, That gives you velocity. You change the velocity with respect to time. That gives you acceleration. But if you change the acceleration with respect to time, you get something else that has a special name. Y'all do realize that you don't feel velocity if you're in your car. If you go 60 miles per hour, you go to sleep. Somebody hits the brakes, you feel acceleration and you wake up, right? Or you're going and you're asleep and somebody turns the wheel real quick and changes the direction, which is a change in velocity. That wakes you up. Okay? So you're changing the velocity, and that's what you notice. You notice acceleration in your car. That's what you feel. That's what your brain detects. But if you have a change in velocity with respect to time, what is that called? What happens to you when you hit the brakes really hard, which would be a big negative acceleration? What happens to you? What does your body do?
You swing forward.
Yeah, you continue to move forward. You feel a
Force, inertia.
yeah, you feel yeah. Okay, ladies. We're going to let the ladies answer the question. Guy shows up late for homecoming with a crushed flower. What would you call him? Loser's not the right term, but that's okay. Try another term. Okay, don't say bad words. J word. Begins with a J. You might call him a jerk. That's what you feel, right? You get a really quick change in acceleration, you feel a little jerk. The guy shows up. Guy doesn't show up. Jerk that your brother looks for and finds. It hurts. But the whole deal is jerk is really the term. I'm not joking. I know y'all think Mr. Evans makes a lot of this stuff up, and I do. But in this case, yeah, it's a jerk. Change it, and you feel that. All right, I am done. When you look at the